we will begin our adventure into Chapter 2. Okay? Chapter 2, we are going to find some review topics. I will just throw that out there. All right? But there are topics that we want to expand with. Okay? Or we may do things a little differently. All right? So first of all, I have written up here quadratic functions and models. Quadratic. What is a quadratic function? Okay, a polynomial with an x squared. So let's be more specific. There's an x squared. Is there an x cubed in there? No. So 2 would be the highest degree, right, of our variable, right? When we graph quadratics, what do we get? Parabolas, right? And we've worked with some quadratics with transformations, right? Okay. So, first of all, like Sean said, there we go. Okay? A quadratic function is given by ax squared plus bx plus c. So, we have x to the degree of 2, that's its highest power. All right. A, B, and C need to be real numbers, and A.
They're not equal.
Yep. A is not 0, otherwise we wouldn't have a quadratic, right? Okay, this is something that you know. You don't have to write this down word for word if you don't want to. Okay, you write down what you think you need to. Right? So this is a quadratic function. Okay? Now, back in your Algebra 2 days, how did you guys graph these? How did you go about graphing the parabola? You remember?
A table of values.
A table of values where you needed to find the vertex, right? And you had a way of doing that. Okay. Well, no more table of values, right? Because we know how to take a quadratic and transform it, right? So, what we're going to do is we're going to write our quadratics in standard form, which looks like this. Okay? A times x minus h squared, quantity squared, plus k. That way, we know if we have a vertical stretch or shrink, and then horizontal and vertical shifts. Now, if we take a parabola, our parent function x squared, and we shift it right h and up k, then hk is our new vertex, right? If we shift horizontally h and vertically k, that is where our new vertex is, okay? So looking at standard form, we're going to easily be able to pick out our vertex, okay? Because we're just looking at that horizontal shift and vertical shift. Okay, that 0, 0 vertex from our parent function is being shifted h and then k. I have this dotted line going through my parabola. What's special about where I drew that dotted line?
There's symmetry in the parabola.
There is symmetry in the parabola about it. Do you remember what this is called? Symmetry is a key word. Yes. Okay. This line that goes through our vertex, this vertical line, is called our axis of symmetry. So since it's a vertical line, okay, cutting through HK, we're going to call it x equals h. X equals whatever that x coordinate is of our parabola. So in your homework, it will ask you to identify the vertex and axis of symmetry often. Okay, whether it be you have a graph or you're just looking at the equation. Okay, these are two things you need to be able to pick out. Okay. Now let's talk about this. What happens with our parabola, or what does our parabola look like if A is positive? Show me with your arms. Oh, some good function aerobic arms here. All right, very good. Okay, it goes up, and then if A is negative, our parabola is going to open down. Okay, excellent. So, if we have this, you don't need to write this down. This is like, let's think about this. If we have standard form, we can easily take our parent function and stretch it or shrink it if we need to, and then shift it, right? These quadratics are going to be very easy to graph if they are in this form. Okay? Now, sometimes they are not going to be in this form. Okay? Sometimes they will just be a trinomial. If that's the case, then we need to force it to be in standard form. And so we need to review how to complete the square. Okay. So I want to talk about a couple things first. Okay. As a side note, x squared plus 6x plus 9. What does that factor to? X plus 3, the quantity squared, okay? So this is a perfect square trinomial that factors to the square of a binomial, okay? So our goal is to rewrite this up here so that we can have this piece right here. We need a binomial squared. Okay? Now, what is the relationship between this number and this number? Half. Okay? So we call this number b, which means this number would be b over 2. Right? Okay. That is the pattern with every single perfect square trinomial. Right? So what we're going to do here is we are going to rewrite this. This is not a perfect square trinomial. If we can't even factor this, can we? Multiply to -1, add to -6, we can't even factor it, okay? So finding zeros right now really isn't very nice, okay? So what we're going to do to write this in standard form is I want you to group anything with an x together, and we are going to add something to that to make it be a perfect square trinomial. Okay? Now we still have this -1. Am I allowed to just add something to my function? No. Okay, so we need to balance this out. Okay? Now we can either add the same thing to both sides, or what would our other option be? We could add something to one side and then how could I balance it out a different way? Okay, so you guys are comfortable like adding the same thing to both sides, right? Would you agree that if I add and subtract the same number, it's not changing the equation? Right? So if we add and subtract the same number, then we're not changing the value of our expression. Okay? So this first blank right here, this is going to be our perfect square trinomial. So what is b?
6.
Okay, so b is -6. So b over 2 would be -3. Now does -3 go here?
No.
-3 squared needs to go here. Okay, so now we have x squared minus 6x plus 9. What does that factor to? X minus 3, the quantity squared. 6x squared minus 6x plus 9 factors to x minus 3 the quantity squared. And then out here we have what? Minus 10. Now, this looks like standard form. Before we move on, are there any questions? Okay, where? Okay, so if we look at our trinomial, like the one that we looked at before. Oh, let's look at a different one, like x squared plus 10x plus 25, right? And this factors to x plus 5 quantity squared, right? So anytime we have a perfect square trinomial, this number right here, if we cut it in half and square it, will always be this number. Okay, so 10 cut in half is 5 squared. Okay, if we look at, here's another one. This factors at x plus 2, the quantity squared. If we cut this in half, we get 2, square it, we have 4. Okay, so that's the pattern of a perfect square trinomial. So if we look at whatever this is, if we cut it in half, we square it to make that fit our pattern. Right? Would it be better if I wrote this as 9 instead? Would that make it still more comfortable? Okay. All right, it is 9. Does that feel better? Okay, so x squared minus 6x plus 9 factors to the x minus 3 the quantity squared. Okay? Most important thing, we got to take b over 2 and cut, we have to take b over 2 and then we square it to get this number right here. Okay. Now, let's talk about graphing this. This is a parabola that's shifted where?
3 to the right, or down to
Right? Easy to graph now in standard form. Okay? Where is our vertex? 3, negative 10. H, comma, K. Right 3, down 10. However you want to think of it. Where is our axis of symmetry? Okay, don't just write 3. Our axis of symmetry is a line, so we need to write x equals 3. Now, what if I asked for zeros or x-intercepts?
the zeros. Can't we just like go back to the original problem and solve for zeros?
Okay, so what I want you to do is go to here. Okay, don't go to the original, go to here. And we're going to plug 0 in for what? Okay, so if we plug 0 in for y, we have x minus 3, the quantity squared, minus 10. Okay, because from here, it's set up very nicely for you. Okay, you don't have to do any factoring. We've already done it. So talk me through this. How do we solve for our zeros? Add 10. Then what? Square root both sides. We have x minus 3 equals plus or minus square root of 10. We're solving. When we square root both sides, we have to account for the positive and the negative.
Isn't that just assuming when you still have the square root over it, though? Like, because you haven't actually taken it yet? Like, because you haven't actually done the square root of 10. So you don't plus or minus until you actually take it.
No. Anytime we solve, we have to think about, because we have to think about like going backwards, right?
Yeah.
So if I go from this step to this step by like squaring both sides, right?
Yeah.
Then positive 10 squared is, or positive square root of 10 squared is 10, negative radical 10 squared is 10.
Yeah.
Okay, that's why we have to do it. So those would be our zeros. Okay, you will be asked to do that in your homework tonight. All right, don't go back to the original problem and do the quadratic formula or factor or whatever. When we have this in standard form, it's an easy 3-step problem. Move your h over, square root both sides, or move your k over, square root both sides, move your h over. Okay, 3 steps maximum. That's nice. Yes, because these would be exact. Right? Okay, now, if you remember from completing the square, we have a rule. Okay? First of all, does anybody is this kind of coming back from last year completing the square? Okay? Do you remember the one rule we have with completing the square? It's okay if it doesn't. We have a rule though. We can only complete the square when the coefficient is 1. Okay, Mrs. Holman, what happens when the coefficient is not a positive 1? Okay. If the coefficient is not a positive 1, then we have to factor it out. Okay. What is our coefficient in this problem? 2. Okay. I am not going to ask you to factor it out of everything. What I'm going to ask you to do is just factor that coefficient out of your x terms. So since 2 is your coefficient to x squared, I would like you to factor 2 out of x squared and 8x. Okay? And then we're going to put our mystery number in there. Okay? Now, the plus 7, that doesn't have an x attached to it, so we're going to still just leave it outside. That 2 is not being factored out of it. That's why I put it after the parentheses, okay? Now, if we add a number, okay, we also have to subtract it. So we're going to still do that step. All right? So now let's complete our square inside. What is b divided by 2? 2 squared would be 4. Okay. What are we really adding to our equation? Are we adding 4?
No. 8.
Okay. This 4 is being multiplied to that 2, which means we're really adding 8. So out here, where that 2 is not affecting the plus 7, we're going to have to subtract 8. Okay. That mystery number has to be multiplied to that coefficient since it's inside the parentheses. Right? So what do we have? We have 2 times x plus 2, the quantity squared, and then minus 1. Where is our vertex? Okay, this parabola has been shifted left 2 and down 1, so our new vertex is at -2, -1. Okay, and this right here is doing what to our parabola? A vertical stretch. Very good. Where is our axis of symmetry?
Negative.
X equals -2. I'm not going to go through the graph of that one because I just gave you a test over graphing our transformations, right? We're going to save our time. Now, I want to ask you something about the shape of our parabola. What would be special about the vertex if our parabola is opening up?
It's the minimum.
Okay, it's not necessarily positive because I can throw an x-axis right here and that would be a negative vertex, right? Okay, Tyler, what did you say?
It's the minimum.
Okay, it's the lowest point ever. It's the minimum on that graph. Okay. What about the vertex here? It's the maximum. It's the biggest. It's the highest point on that graph. Okay. So if there's a question that asks you for some highest value, and you have a parabola opening down, then you'd be looking for the what? The vertex. Excellent. One last example. I would like to find the standard form of an equation that has a vertex of negative 411 and it goes through the point negative 615. Okay, so let's talk about standard form. This is standard form, correct? Okay. What do we know? Can we fill in anything with that standard form? Okay, our vertex is at negative 411. So we have y equals a times x plus 4 squared plus 11. Okay. Now we need to figure out a. Yes.
We can plug in the point for x and y and solve for a.
Excellent. We know that the point negative 615 lies on our parabola. So if we plug negative 615 into our equation, it should satisfy it. So what we can do for this y, we can plug a 15. For this x, we have a negative 6. And now we can just solve for that a value. All right. So we have 15 equals a times 4 plus 11. What's nice when we get to pre-calc, we don't have to do, I mean, we can do some things in our head, right? I will let you do this in your head. What is a? 1. So we can write y equals 1 times x plus 4 squared plus 11. Okay, so before I give you your homework, I am going to put a problem on the board that I want you to do the completing the square so I can make sure that we can understand it before you go home. Ready? And we can just pause this real quick.